Alright, this is for the metal detector. First thing to do is make a oscillator circuit to make a sine wave. It's supposed to be at just a hair over 7 kilohertz. Then we buffer it, and then this is an inverting amplifier. So this makes, you can see that the orange is inverted from the blue, so it's the opposite phase. And then I've got it to where I can adjust the amplitude of the regular wave, and then I can also adjust the amplitude independently of the out of phase pulse. And the point of that for the metal detector is you got your two coils. See, this one's already wrapped. This is the outer coil, and I haven't wrapped the inner coil yet. But they're on the same horizon, right? So this is creating an EM field, and it's going to just automatically get picked up by the receiving coil. So what you do is you wrap the receiving coil, and then over top of the receiving coil you wrap another coil, which is the same. You wrap it the same as you would for this, only for the smaller one, but you wrap it in the opposite wrapping direction as you can wrap it in the opposite wrapping direction. But since what I'm doing is creating two separate current sources, one in one phase and one in the other phase, I will be wrapping it the same direction as this and putting the opposite out of phase pulse through it. So what happens is this opposite out of phase pulse that's wrapped over top of the receiving coil is going to cancel out any EM that's going straight sideways. So any EM that's going straight sideways to the receiving coil is going to be blocked and canceled out by the opposite phase. So that's how you keep it from just non-stop going off, because it's picking up what's coming from the outer coil. You block it, and you only want it to pick up what is bounced down off of a piece of metal and bounce back up. So you're basically putting a barrier in between these two coils by having a separate coil with a 180 degree phase to block out anything coming sideways. Now there's a name for that when the two coils are on the same plane, horizontal plane. Coplanar. It's called coplanar coils. So we're just blocking out the sideways action, but it's still going to get what goes down, hits a piece of metal, and bounces back up. So to get this, we make an oscillator, and we got one inverting op amp and one non-inverting op amp, and they're both adjustable separately. So that's what I've done right here. I've made it so I can, this is my test rig, so I can change some things. That's why I've got the resistors that can be easily changed. So this is the adjustment pot for the non-inverted, and this is the adjustment pot for the inverted. And in this circuit, the only difference is I got one extra stage to just buffer the output of the oscillator before it goes over to here. So I got an extra buffering stage in there. So I got this set up like this, and I got my oscilloscope leads, and here's the output. I've got them adjusted quite differently, but the output is correct. You know, they're 180 degrees out of phase, and I can adjust them independently of each other. The only problem I've run into is the frequency is higher than the simulator says it should be. It should be 7.05 ish, and I'm getting like 7.8 or close to that. Let me see if I can adjust it a little bit. That right about there. That right about there. 7.8. Yeah, the frequency's off a little bit. I might have to adjust that, but the concept's working. Once I get the frequency where I need it, because I designed the coil to be at that specific frequency, so that's going to mess up the coil. But once I get the frequency down to closer to 7 kilohertz, then I've got a simulation of what that will do. Now this is the simulation of wait, there we go. This is the coil. This is the added resistance of what the coil resistance would be, and I'm putting it in series with a capacitor. So this is a simulation of that, and so once I get the frequency in tune, then I'll put the coil in a series with the capacitor, and then try to fine tune the coil to the frequency. And then when it's correct, you see I've only got let's see, 2 volts amplitude, and you can see it's at plus minus 20 volts. So once the frequencies are in tuned, it's going to really ramp up the voltage on its own because of the resonance. So that's how you know when they're in tune. They really, the voltage goes up crazy like. So that's why I made this circuit so it's completely and utterly adjustable, so I can figure out what exactly I need in the final circuit board. This is just my test rig to test every aspect of it and have it all adjustable and stuff. And that's what I'm getting out of it. Just got to adjust the frequency. Alright, that's it.